Good morning, good afternoon, ladies and gentlemen. This has been the biggest fear of my entire career, being the last speaker before lunch. Horrible, but here I am, so please be supportive, stay with me for this keynote. I'll be talking about cybersecurity for SATCOM. I use the two buzzwords in my title to try to catch the audience. Zero trust, which you may have heard already this morning, and also multi-orbit. I'll try to demonstrate what is exactly the challenge in securing multi-orbit connectivity, and also while minimizing the trust you may put into the third-party infrastructure. My name is Mathieu Bailly. I represent CySec. We are very much of a new space company, founded in 2018. And I'm so glad that today cybersecurity has been becoming really a mainstream topic for the industry. Back then in 2018, not many people were talking about this. So I'm super glad to be here on stage today to address this topic. All right, let's see this works. Let me try to begin with a little story about Captain Midnight. If you're familiar with the security for SATCOM, this is a very classic story of the first incident reported publicly about jamming a satellite. This was done by somebody named John McDougall. He was an electrical engineer working at a teleport in Central Florida in the States. And he was not happy. John was not happy because HBO, TV service provider back then, just increased the price of the service. And John was really mad. And he was working at the teleport, controlling the antennas that were beaming the service to the satellite. So what he did after the shift of his day is that he steered the antenna, looked up the coordinates of the HBO satellite called Galaxy 1, and he overpowered the movie that was being streamed for the clients. And he managed to have this message here broadcasting on live television in the whole North America, saying, "Good evening," very polite, John, thank you, Captain Midnight, are you kidding, $12.95 a month? This is too expensive. That was the first incident about satellite jamming, 1986. And then things progress forward, but slowly until 2019 with this little guy there. His name is James Pavor. He looks like a teenager. Back then he was a researcher, a doctoral student at the University of Oxford. And he did his PhD about SATCOM security. What he did is that he bought some TV equipment worth about $300, and he managed to put it together and to listen to the signals that were broadcasted from all the different geo satellites. And what he was able to find out, very surprisingly, is that the traffic was mostly in clear, not encrypted. He was able to have access to very sensitive data, such as personal data, data for navigational charts, personal communications, SMS, in-flight information, and so on and so on. So he showed that with a very simple setup, very cheap, he was able to listen, to eavesdrop data that were not supposed to be in clear, really showing that this was possible, and this is a challenge that the industry might be able to address. And the last example I want to talk about is the Viasat attack, which is kind of the consequence of all these incidents in the real world with massive impact on the industry. They made the headlines for weeks and weeks. Very unfortunate for Viasat. As you may know, so the Ukrainian, the Russian army managed to find a vulnerability into a VPN connection to the Viasat operations center of the KSAT satellite, and then they managed to beam up and down a malware called the acid rain that disturbed and totally shut down thousands of terminals that were used by the Ukrainian army. And this is the first example where we have a state-sponsored group from Russia targeting, attacking a commercial satellite provider. So this really shows that the frontier between governmental, military, and commercial is very thin, very thin. All right. These challenges, what exactly are they? So I mentioned a couple of examples. It is possible to spy satellite communication from the ground. You can listen to ground antennas, be able to, exactly like James Pavor did. You can also do it from space. So there are multiple ways to eavesdrop and to have access to data that you're not supposed to have to access to. And the solution today is quite tricky, because on the internet, when you want to protect your traffic, first thing you think about is putting a VPN on the connection. Well, putting a VPN on a satellite communication is possible, but it comes at the extent of a massive drawback, massive setback in terms of throughput. So it really damages the performance of your link. So it's the new trade-off. Usually you have to decide about whether you want to have a secure connection or a highly performant connection. And this is exactly the problem we want to solve at CySec. The goal is to combine both, so that satellite communication users will not have to choose between security and performance. Another issue, I mentioned zero trust at the very beginning, is that today, if you're users of satellite communications, you have to trust quite a lot of suppliers in terms of third-party infrastructures that are needed to operate and to provide the communication service. This is a map of various ground stations and different infrastructures that are located in sensitive geographic areas. And these are used on a daily basis to broadcast sensitive data from governments, from commercial users. And we do not control these infrastructures. So how do you deal with that? How do you deal with the risk that the infrastructure you rely on to provide your service maybe have a different threat model than you do? So that's kind of the summary of the situation between GEO communications and LEO. In GEO, obviously, as I said, with the example of James Pavor, communications have been mostly done in clear, with the problem of applying a VPN or encryption on the link, which damages the performances. And what we heard a lot is that for communication service providers, this is not the problem. This is the problem of the customer, which at the end of the day doesn't have the resources, the expertise to solve it. So that's why we end up with traffic which is very much unencrypted. And there is no easy fix, so we need to find a solution. LEO is a bit different, as we have LEO constellation providers that are more recent companies, so using more modern tools. We're talking about DevOps, for example, so tools of software that are really popular with software engineers in the cloud, like Docker, containers, Kubernetes, and so on. SpaceX is obviously a great example of that. They've been doing a really good job at embracing these new tools to provide security by design. But this is easy when you start a company, a young company, when you have young engineers. If you have a lot of legacy, it's harder to shift and to change a bit the way you've been doing things. Traditional tools to secure the traffic may or may not work, typically VPNs, and I'll come back to that later. And it remains a challenge, either for legal obligations. For example, Starlink going to France, they have to make sure that the French government have access to some of these data, so that's not easy. And also the question of trust of using a third-party infrastructure, as I talked about before. Typical use cases for confidential satellite communications that really need to protect these data, they are very classic. I'm going through very quickly. So critical infrastructure, power plant, and so on and so on. Military for the welfare, so soldiers on the battlefield that need to check WhatsApp, talk to their families, maybe watch Netflix. Diplomatic networks, embassies all around the world, surveillance and tracking, border control, these topics, and mobility, maritime, business aviation. If you have the CEO of your company flying in a private jet and the communications are all in clear, may be a problem for your company. Let's talk a little bit about zero trust to demystify a bit what the word means. I took the definition from the NIST, which is a very highly regarded standard from the US, that defines zero trust as no implicit trust granted to assets or user accounts based solely on their physical or network location, which is a very theoretical way to say you want to trust the least amount of people as possible. It is realistic. It's difficult because you have to trust most of the time the CPUs, so really the basic nodes of your infrastructures that are manufactured by billions of pieces and are just impossible to make it customized for you. So you have to trust Intel or other providers. And also, one very powerful tool to keep the trust is cryptography. And this really comes down at the end of the day of the level of trust you may have in the secret, in the cryptographic keys that will protect your communications. And I'll come back to that later. What we do at CySec to solve this problem, we have a new product called GOVSATCOM, which is coming on top of a classic SATCOM link, LEO or GEO, on both ends of the link to provide end-to-end security. And what the software does is that it combines acceleration to maximize the throughput of the link with security. So we combined a PEP, performance enhancing proxy, with TLS-based cryptography to have the best of the two worlds and to not be able to choose between security and performance. I have two examples of results we got. We were supported by the European Space Agency via the ARTES program, and we were able to test the software in both GEO and LEO links. In GEO, these are the results we got, and you see that we even managed to get better performances in terms of throughput. This is the throughput in kilobyte per second than the plain link. So again, that shows that you can implement security without compromising on the performance of the link. Same thing for LEO. I added here for your information the results we got with a traditional VPN that you can buy off the internet, for example, OpenVPN. And you see the huge setback in terms of throughput when you have only the VPN. And it shows that if you combine an ad hoc accelerator, really custom-made for satellite communications, and TLS-based cryptography, you can have a slight step back, about 10% of the throughput, while having a very secure crypto end-to-end to protect your communications. And now the challenge to make it multi-orbit. So what we're doing today is to fit these two pieces of software into one device, one package, so that it can switch instantly, automatically, depending on the type of link that is used in the modem. So if it's LEO, we're using the accelerator for LEO. If it's GEO, we're using the accelerator of GEO, which is seamless at the end for the user. Every link is different. Come test yours. The technology is now available for testing. We're looking for pilots, for customers, for partners. We have a booth right there, CySec. I'm done, and the very good news that is now lunchtime. Thank you so much.